Guys, and welcome back to more biology with Miss Saxon during the COVID outbreak. So this week, one of the things that you're going to do is a gizmo on peppered moths. In order to really understand what's going on in the peppered moth gizmo, this little presentation is going to give you some of the background information you need to know. All right, so the scientific name for the peppered moth, the specific species that we're talking about, is the Biston betullaria. The story of the peppered moth is one of the best examples of natural selection in action, so you'll see oftentimes that this is an example used to demonstrate natural selection taking place. The peppered moth is most common in Europe, North America, and Asia, and it seeks shelter on trees during the day, but it's vulnerable to being eaten by birds, and birds are their natural predators. Okay, so if you remember from earlier in this lesson, we looked at variation. And variation means that there's two different versions of the same gene. So for instance, blue eyes and brown eyes are variation within eye color. Well, for these peppered moths, there are variations. And the variation in particular is that there's a typica variation, which is the lighter colored one. And so that's this one up here. That's really light in color. And then there's the carbonara, which is the darker colored one. Both of them are moths. Both of them are typically found in nature, but they just have a slightly different color to them. Okay, so before the 1800s, the typica variation was much more common in the English countryside, and that was the speckled gray moths because they blended in really well with the light colored bark on the trees and lichens, which are organisms that live on tree bark. And the dark colored contrasted with the tree bark, and as a result of being contrasted, it was easy for the birds to pick them off. So if you look here, it's really easy to see this dark moth right here, and you and I can see it really easily. The birds could see it really easily too, and as a result of the birds being able to see it, this guy was much more likely to get eaten. I don't know if you've noticed, but this right here is kind of the outline of a typica version. And so that one's really well camouflaged. And as a result, the birds didn't eat as many of those because it couldn't find them as easily. So in the 1800s, the Industrial Revolution took place. And when that happened, the landscape of England changed. So we had coal power factories, and they were spewing out all this dirty smoke into the air because there was no environmental protection. We were just building stuff and making stuff using coal power, and we weren't thinking about the consequences of it. Well, one of the consequences was that it blanketed the forest with soot from burning of the coal. And so the lichens that existed on the tree trunks that helped give the tree color, they all died. And as a result, the trunks of the tree died as well. So what we see here is now it's really easy to see the light colored moths, right? So the birds would go after those. And while you can still pretty easily see that dark colored moth there, when a bird is swooping in and trying to get its prey, it's going to go for the easy target. And so that light one is much easier for the birds to see from a far distance than the dark ones, which it couldn't see till it got real close to the tree. So after the Industrial Revolution, by 1895, the dark moths accounted for about 100% of the total population in some of the forests. The pattern of darkening that we see is described as industrial melanism. Throughout the 20th century, the air quality improved because there were new environmental regulations and things like that. So the trees started to become lighter in color again. And as a result, the proportion tipped back in the favor of the typica moths. So we started to see the variation of typica colored increase. And so today we're back to pre-industrial revolution conditions where there's much more of the typica and much fewer of the carbonara variation within the peppered moth. So hopefully as you navigate into the gizmo, having this understanding of how the trees change and how the different variations of the moths exist will help you. Keep in mind, this is a natural variation that's genetic. So they inherit their color from their mom and dad, because moths have mom and dads too. So this color comes to them genetically, and as a result of those genetics, they're either better able to hide themselves, to camouflage themselves, or they're less able to camouflage themselves. And so hopefully throughout the gizmo, you'll see that those that are better able to camouflage themselves survive. And because they survive, they reproduce. Those that aren't so good at camouflaging themselves get picked off by the predators. And when the predators eat them and they die, they're not able to reproduce. So hopefully that's what you get out of it. We'll see. Have a great day.